So students, today we are going to be continuing our class 12 series, and this is going to be another video about determinants. Today we are going to be talking about a few interesting and important topics, important properties of determinants. Important properties. Okay. So the first one we're going to be learning about says that if you have any determinant of any order, let's say you have a determinant A with order 3, and it has one row or one column with in which all the elements are 0, then no matter what the elements of the other rows or other columns are, the value of that determinant would be 0. You can calculate this yourself. But I mean, this is very straightforward itself. Then I can give you another example. Let's say I have the second column with the elements in which all the elements are 0, and no matter what the elements of the other rows or columns are, the value of this determinant would be 0. Okay, this is the first and important property. These properties are really gonna come in handy when you're trying to solve the MCQs. When I try to take an OMR based exam. The second property says that if in a determinant any two rows or any two columns are the same, are identical to each other, or they are scalar multiples of each other, the value of the determinant would be 0. Let's say I have a determinant with in which the first column is A, B, C, the second column is D, E, F, the third column is also A, B, C. So this property says that the value of this determinant would be 0. You can check this out, you can calculate this yourself. A times EC minus BF, you can do that yourself. Let me actually help you do it. A times EC minus BF minus, this is not BF, that might be wanting in the life. B times DC minus AF plus C times BD minus AE. Okay, this is gonna be the same as ACE minus ABF. Again, not the BF plus 1 in their lives, and as PCD plus ABF plus PCD and minus ACE. ACE cancel out each other. So does minus ABF and plus ABF. So does minus BCD and plus BCD. Okay. So you can see that if determinant, if any two rows or any two columns are identical, or if the scalar multiples of each other. Let's say if this third row in this case was KA, KB, and KC. You can see that this one is a scalar multiple of the first row. Then the value of this one would also be 0. Okay, I'm not going to actually let me do it. This way you'll be able to memorize this a little bit better. So this would just become, I mean, in mathematics, I have always been a big advocate of the fact that you just should not, try to memorize all the formulas. You should try to understand why things are the way they are. And if you master that, only then you will be able to keep them in your head all the time, because in that way you are not memorizing stuff. you know what, why things are the way they are. And even if you have forgotten something about anything I'm going to teaching you today, if you know why things are happening the way they do, you can definitely, can possibly even create your own unique patterns or quote unquote formulas. Okay, and that is what I want. I just don't want to teach students so that I can pass in the exam and basically score full marks. I want to create great mathematicians for the future. Okay, let's evaluate this one. A times EKC minus if KV minus B. Actually, let me do it here. B times DKC minus AFK plus C times DKB minus AKE. Okay, so the value of this one would be AEKC minus AFKB minus BDKC plus ABFK plus DDKC minus ACK plus AEKC, basically the same thing. They would cancel out each other. Minus AFKB and you have plus ABK, same thing again. Minus BDKC plus BDKC, same thing. So again the value is 0. Okay. So you guys know why things are happening the way they are. This works for both rows and columns of any orders determinants. Okay. The third property we are going to be learning about is actually really interesting, and it is going to really come in handy when I try to simplify a determinant if it looks scary. Like, there are definitely a lot of determinants which are going to intimidate you because of how scary they look, how complicated they look. But this one property is definitely gonna help you simplify it a lot, and the calculation is gonna be significantly easier. Okay. So let's say you have determinant A with the elements A, B, C, D, E, F, G, H, I. Okay. Now, if we replace any row or any column with the sum of two rows or the sum of that row or that column and that added with another row or another column multiplied with the scalar, the value of the determinant would remain constant. So what does that mean? Let's say the value of this determinant is k. Let's assume. So this implies, let's say if you have the first row here, if we rewrite this as the sum of first and second row or third row, everything would work. A plus D, B plus E, C plus F, and everything remains same. D, E, F, G, H, I. Then the value of this one as well would be K. Okay, and I know you guys are flabbergasted, like about for because of everything I have told you guys, because That was my reaction as well when I got to learn about this for the first time. I can visibly see that a value of a row has changed here. There is changed drastically, but you're saying that like the value of the determinant as a whole is gonna stay the same. Yes, yes, students, that is true. That is what is gonna happen. And not only that, if I add another row, like let's say I add the third row as well, in that case as well, the value would stay the same. Let's say a plus d plus g, p plus e plus h, c plus f plus I. In that case as well, the value would stay the same. It would be k. Let's say if I minus, if I subtract one row from this one, let's say I subtract this one. In this case as well, the value would remain the same. That is just insane to think about. And not only that, if I multiply a scalar with the row or the column before creating a new one, still value would stay the same. Let's say we have a constant here called m, g, m, h, m, I, m. Okay, the value of this one as well stays the same, and that is just so mind blowing to think about. You can just manipulate so many determinants in so many unthinkable ways. I mean, unthinkable in the sense that you are not aware of how things work in this context prior to this video. At least I would assume so. And like, this is just life changing. This is just so freaking life changing. Sorry for, I'm absolutely sorry for using a bad word here. But you can just see why this thing that amazes me all the time. I like to learn more. The value stays the same. Let me compute this actually. The computation is gonna be really, really complicated. But I'm gonna do it anyway. If this video becomes a bit long, we're not gonna worry about that. The value of this one would be A times EI minus HF minus B times DI minus GF. Guys, don't get excited. Plus C times DH minus EG. DH minus EG, AI minus HF, DI minus GF. This one would be AEI minus AHF minus BDI plus BGF plus CDH minus CEG. Okay, this is the value. Now let's find out what this one would be. I'll have to actually remove everything. Use that on the space left. Let me evaluate this one. This one would be A minus D plus GM times EI minus HF minus P minus E plus HM times DI minus GF plus C minus F plus IM DI minus GF, and this is gonna be DH minus G. Okay, after evaluating, this would become AEI minus AHF minus DEI plus DHF plus GMEI minus GMHF minus BDI plus BGF. No, I'm not telling you guys to be girls. Any girl watching this video will become a GF. If you that's what you are assuming. BDI minus minus plus BGF minus cancels on each other. So plus EDI minus EGF plus HMGF actually there will be an HMDI part of this one with a minus sign in front. So HMDI plus HMGF. Okay, this one would give us CDH minus CG minus FDH plus FG plus IMDH minus IMG. Okay, so AEI would still the same according to this one. Only the stuff considering M's would cancel out each other. I know that. GMEI and IMG with same thing. This one has plus sign, this one minus sign. This would cancel out each other. GMHF and HMGF again same thing. Signs differ, so they're gonna cancel out each other. HMDI and IMTH same thing. Again signs differ, so they're gonna cancel out each other. Do I have anything more? AEI, I don't have any other, I think. AHF2, I don't have any other, I think. DI, I don't have any other. Just DHF minus DHF minus FDH, same thing. This would cancel out each other. Minus DI plus EDI, same thing. Would cancel out each other. BDI would remain the same. BGF would remain the same. EGF minus EGF and plus FG, same thing. That opposites of each other, so they will cancel out each other. And I think now we are good to go. What we're left with is AEI minus AEI minus AHF minus BDI plus BGF, and this one is plus, I think. Yeah, yeah, I got this one comes from here. CDH, so plus, yes. This one is plus CDH, and this one is minus CG. You can see that this one and this one are the same thing. So this was the proof of this our third law of determinants. I mean, third property that I'm teaching you guys in this video. That when you take a determinant and you take any row or any column of that, and if you replace that row or column with the sum or difference of that row or that column, and another row or another column, or another row another column multiplied with the scalar, the value of that determinant remains the same. And this is gonna be a really crucial uh, property of determinant, and this one is gonna be coming handy absolutely the most. I absolutely love this one. You can just see that how like enthusiastic I am about this. Okay, I think that was a lot for the day. I would like to end this video here, and if you guys think that you have any doubts regarding anything I've taught in today's video, please do let me know in the comment section, and I will try to resolve that. And until then, keep learning.